Welcome to True Projects. In this video, we are going to explain about the project titled Inquest of Current Situation in Afghanistan under Taliban rule using sentiment analysis and volume analysis. In this project, extensive English text data from diverse sources such as news articles, social media, and reports is processed and analyzed using advanced data analysis and machine learning techniques. The primary aim is to gain a comprehensive understanding of the current situation in Afghanistan, particularly under Taliban control. This involves extracting valuable information, trends, and insights from the textual information available. Afghanistan is currently undergoing significant and rapid changes, making it essential for individuals, governments, and organizations to stay informed. This project plays a crucial role by providing insights into public opinions and emotions. It also quantifies the volume of information circulating, reflecting the level of global attention on the region. This information is invaluable for making sense of the evolving situation, assessing its impact, and adapting to changing circumstances. The project's key distribution lies in offering valuable insights into the ongoing situation in Afghanistan. These insights are not only beneficial for decision makers such as policymakers and organizations, but also for the general public. By understanding the dynamics, potential risks, and opportunities in the region, decision makers can develop more informed strategies and allocate resources effectively. Simultaneously, the project serves as a valuable resource for the public, fostering greater awareness and understanding of the complex situation in Afghanistan under Taliban. The primary objective of this project is to thoroughly examine and comprehend the current circumstances in Afghanistan while it is under the control of the Taliban. This is accomplished by processing and making sense of a diverse set of English text data from various sources. The project's primary goal is to obtain a deep understanding of the dynamics, events, and developments within the country, providing valuable insights into its evolving situation. To achieve the project's objectives, a range of machine learning algorithms is employed. These include logistic regression (LR), random forest (RF), extra-tree classifier, multinomial Navy Bayes (MNB), and more. These algorithms play a pivotal role in creating models and interpreting the data. Their purpose is to uncover hidden patterns, relationships, and trends within the textual data, ultimately facilitating predictions about the situation in Afghanistan. The selected algorithms serve as powerful tools for extracting valuable insights from the text data. They enable several critical tasks such as sentiment analysis to understand public emotions, topic modeling to identify relevant themes, and predictive modeling to anticipate future developments within Afghanistan. Collectively, these algorithms provide a holistic view of the situation, enabling the project to assess public sentiment, pinpoint essential topics of discussion, and make informed projections about the country's future under Taliban rule. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of Wi-Fi and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. This initial step involves bringing in software packages and libraries like NumPy, Pandas, Matplotlib, Seaborn, etc. that contain pre-built functions and tools. These packages are essential for various tasks throughout the project, such as data manipulation, analysis, and visualization. Exploring the dataset. English text for analysis. In this phase, the project examines the dataset containing English text data related to the current situation in Afghanistan under Taliban rule. The objective is to understand the dataset structure, content, and characteristics, which is crucial for effective analysis. Data processing. Data processing encompasses tasks like cleaning and organizing the dataset. It involves removing irrelevant information, handling missing values, and ensuring data consistency. This step prepares the data for further analysis. Visualization using Seaborn and Matplotlib. After data processing, visualization libraries like Seaborn and Matplotlib are used to create graphical representations of the data. These visualizations, such as charts and graphs, help in gaining insights from the data and presenting findings in a more accessible and understandable manner. Feature selection using formal data. Feature selection is a process of choosing the most relevant and informative attributes, features from the dataset. Formal data analysis techniques are applied to determine which features are essential for the project's objectives and which can be excluded. Lexicon vectorizer. Lexicon vectorizer involves converting text data into numerical representations. Lexicons or dictionaries are used to map words or phrases to numerical values. This transformation is essential for machine learning algorithms to process and analyze the text data effectively. Splitting the data to train and test. In machine learning, it's crucial to divide the dataset into two subsets, one for training the model and another for testing its performance. This split allows for model training on one portion of the data and evaluating its accuracy and effectiveness on the other, helping to ensure the model generalizes well to new data. Building the model, in which we have different algorithms. LR, logistic regression proposed. Logistic regression is a statistical method used for binary classification tasks. In this context, it could be used to classify text data as expressing positive or negative sentiment. The proposed indicates that it's one of the methods being considered for the project. RF, random forest. Random forest is an ensemble learning technique that combines multiple decision trees to make more accurate predictions. In this project, it is used for tasks like sentiment analysis or topic modeling. Extra tree classifier. The extra tree classifier is another ensemble learning algorithm similar to random forest. It's effective at handling complex data and might be used to model and predict aspects of the situation in Afghanistan. KNN, K nearest neighbor. KNN is a classification algorithm that assigns data points to the most common class among their K nearest neighbors. It is used to classify text data based on similarity to other data points. DT, decision tree. Decision trees are used for classification tasks by creating a tree-like model of decisions and their potential consequences. It's an interpretable method that might help in understanding the factors influencing the situation. MNB, multinomial Navy Bayes proposed. Multinomial Navy Bayes is a probabilistic classification method. It's proposed, indicating it's under consideration for tasks like sentiment analysis. SVM, support vector machine. SVM is a powerful classification algorithm that tries to find a hyperplane that best separates data points into different classes. It is used for text classification among other tasks. MLP, multi-layer perceptron. MLP is a type of artificial neural network used for various machine learning tasks, including text classification. It can capture complex relationships in the data. Voting classifier. A voting classifier combines the predictions of multiple machine learning algorithms to improve accuracy. It's a way to harness the strengths of various models for better overall performance. RNN, recurrent neural network. RNN are a type of neural network particularly useful for sequential data. They can be used for tasks like sentiment analysis when the order of words in text matters. LSTM, long short-term memory proposed. LSTM is a specialized RNN architecture designed to capture long-range dependencies in data. It's proposed for the project, indicating it's considered for tasks requires memory of past information. CNN, convolutional neural network proposed. CNN are commonly used for image analysis, but they can also be adapted for text data. They might be proposed for tasks involving text structure recognition. Training the model. This phase involves using labeled data where the outcome is known to teach the machine learning models how to make predictions. Models are trained to recognize patterns and relationships in the data. In the context of this project, training the models would involve providing them with text data and associated labels, that is positive or negative sentiment, to learn how to analyze and classify text data effectively. This step is crucial for models to make accurate predictions and provide valuable insights in subsequent analysis stages like sentiment analysis and volume analysis. Building the model with extra tree classifier gives better accuracy. This module involves selecting the extra tree classifier. An advanced machine learning algorithm has the primary model for the project. The choice is made because it has demonstrated superior accuracy in modeling and predicting aspects of the Afghanistan situation. This classifier will be trained on relevant data and used to make predictions, providing valuable insights into the current scenario. Flash framework with SQLite for sign up and sign in. The project utilizes the Flash web framework combined with the SQLite database to create a user authentication system. This allows users to sign up and sign in securely, ensuring that only authorized individuals can access and interact with the project's features and functionalities. User gives input. In this interactive phase, users provide input or queries related to the current situation in Afghanistan. These inputs could be questions, keywords, or any text-based inquiries aimed at gaining insights or information about the situation. The given input is pre-processed for prediction. Once user input is received, it undergoes pre-processing. This involves cleaning and structuring the text data to prepare it for analysis. Pre-processing steps may include removing irrelevant characters, tokenizing, and converting the text to a format suitable for analysis. Trained model is used for prediction. After pre-processing, the user's input is passed to the trained machine learning model. The model leverages its learning from the training phase to analyze the input. Depending on the project's objectives, this could involve sentiment analysis, topic classification, or other forms of analysis to generate meaningful insights. Topic modeling using LDA. Topic modeling, specifically latent directed allocation (LDA), is employed to uncover hidden themes or topics within the analyzed text data. LDA helps in identifying and categorizing key subjects or discussions related to the Afghanistan situation, providing a structured view of the content. Final outcome is displayed through front end. The project's findings and insights, including sentiment analysis, topic modeling results, or other relevant information, are presented through a user-friendly front-end interface. Users can access these outcomes, making it easier for them to understand and interpret the current situation in Afghanistan under Taliban rule. The front-end serves as the portal for users to interact with and benefit from the project's analysis and findings. Comparison graph. This is the accuracy comparison graph, in which on the x-axis we have algorithm name and on the y-axis we have accuracy score in percentage. So from this graph we can conclude that extra tree classifier performs well. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the correct directory to the code folder's path. Compile the app.py file using the command python space app.py. I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flash framework will host the application locally at the default address, that is 127.0.0, and port, which is 5000. Now copy this local link. I'm copying the link. And paste this link into any web browser. I usually prefer Google Chrome. Now hit enter. The home page of the project is displayed in the browser. This is the front end built using Flash framework. So now click on sign up. If we are a new user, we need to register first, but I have already registered, so click on sign in button. So here we need to enter the username and the password which we have created. So I'm entering the username and the password and click on register. This is the home page of the project. Here we need to enter the name of the book and the favorite paragraph from the book. After entering the paragraph, we will get the sentiment for that paragraph. So I am entering the name of the book. So I have entered the name of the book and this is the favorite paragraph from that book. Now click on submit. So here we can see this is the sentence which we have entered and we got the sentiment as neutral. So here we can see sentiment analysis of the entire paragraph is positive and we even got the probability score for positive, neutral and negative, and the complete sentiment for the sentence is neutral. And the topic for the paragraph is most dependent upon these words. Now we will enter one more sentence and check the sentiment for that sentence. I'm entering the favorite paragraph and the name of the book. Here I have entered the name of the book and the paragraph from the book. Now click on submit. So here we can see this is the sentence which we have entered. And the sentiment for this sentence is negative, and we got the probability score for negative, neutral and positive. Sentiment analysis of the entire paragraph is positive, neutral, negative. These are the probability scores. The paragraph is negative and the topic for the paragraph is most dependent upon these words. Now click on prediction. Here this is the text box. We should enter a message and after entering the message we will predict the sentiment of the message. So here I'll enter a message. This is the message which I have entered. Now click on predict. Results for the comment is this is the message which we have entered. The text type is 0. The tweet type is negative. The topic for the paragraph is most dependent upon these words. Now we will enter one more message and we will check the tweet type. So I'm entering one more message. This is the message which I have entered. Now click on predict. So here we can see the tweet type is neutral and the topic for the paragraph is most dependent upon these words. Now let us enter one more message and check the tweet type. So I'm entering one more message here. This is the message which I have entered. Now click on predict. So here we can see the tweet type is negative and the topic for the paragraph is most dependent upon these words. So in this way, by entering the messages, we can predict the tweet type. Now click on sign out. And the conclusion of the project is After an extensive exploration of various machine learning algorithms, including those proposed for the project, it was determined that extra-tree classifier, especially when utilized in an ensemble model, achieved the highest accuracy. This choice was pivotal because it enabled effective modeling and prediction of the complex Afghanistan situation. The extra-tree classifier is the preferred model as it consistently delivered the most accurate results, making it the cornerstone of the project's analysis. The project utilizes Flask, a web framework, and SQLite, a lightweight database, to create an intuitive and user-friendly platform. Here, users can easily input their questions or inquiries. The system then takes these queries, processes them, and subjects them to analysis using the trained model. This seamless and straightforward user experience ensures that the project is accessible to a wide audience regardless of their technical expertise. Employing latent direct link allocation (LDA), the project uncovers essential themes within the textual data. These identified themes are subsequently presented through a user-friendly interface. This empowers users to gain valuable insights into the rapidly changing situation in Afghanistan under Taliban by providing a structured overview of the content. Users can stay informed and make well-informed decisions amidst the evolving Afghan context.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.